Hello, this is going to be lesson A3, Special Factors. Special factors are like little rules that help us do the factorization of different polynomials. Okay, here I have perfect square trinomials. Before I can talk a little bit more about this, let's understand what a perfect square is. A perfect square is, and here I have a list of perfect squares from 1 to 144. Perfect square is any number whose square root is a whole number. So for example, square root of 9 is 3, square root of 64 is 8. So all of these square roots give me a whole number. So all these numbers here are perfect squares. A perfect square could also be a letter. So for example, if I have the square root of x squared, I would get x, and x squared would be then a perfect square. Okay, x to the fourth also be a perfect square because the square root is x to the second. Okay, and so forth. X to the sixth would be x to the third. So if you notice, if the exponent is even, that means you're going to get a perfect square. And basically the square roots, you just divide the exponent by 2. Okay, so here's another example. X to the 10th. The square root of x to the 10th is 10 divided by 2 is x to the 5th. And here's x to the 20th. 20 divided by 2 is x to the 10. Alright, now that we have a general knowledge of perfect squares, let's go back over here to these rules. These rules apply if you ever see a trinomial whose first term is a perfect square and the last term is also a perfect square, then you might be able to apply this rule, okay, and get a shortcut to getting a factorization. Okay, so let's see how we use these formulas on an actual problem. Here I have a trinomial, and at first look we try to factor anything from the first three terms, and we cannot factor anything. Then we notice that this is a perfect square and this is a perfect square. That's an indication that maybe I can use these formulas. Second thing is, I notice there's a plus, so I'm going to be focusing on the first formula because there's a plus right there. Now I need to check if this qualifies. Okay, basically the middle term has to be 2 times the square root of the first term times the square root of the second term. So basically, in order to check, let's just do this. Just write 2, open 2 sets of parentheses, and a is like the first term but the square root of it. So what's the square root of m squared? M squared would be m. And then this one would be the square root of the last term, which in this case would be 5. And basically, to check if we can use this formula, we need to multiply. 2 times m times 5 is 10m, and that matches. So that means this right here can be used. In other words, this here is the same format as this guy. So that means my answer is going to be the first term, which is m, plus this guy right here, the second term, 5. Okay, and that's it. So instead of having to do your factorization, you can just use this formula. Okay, so let's go on to the next problem. Always ask yourself, can I factor anything from all 3? In this problem, I can. If I factor out, I can factor out a 2, so that the first term becomes 4x squared minus 12x plus 9. Now, I notice that I have a perfect square for the first term and a perfect square for the last term, because the square root of 4x squared is 2x and the square root of 9 is 3. So that means I probably can use this formula right here, but actually it's going to be the second one because I have a negative. Alright, final check. You write down 2 times 2 parentheses, and let's take the square root of 4x squared. So the square root of 4x squared is 2x. So we put it there. And the square root of 9 is 3. And then we check. Does 2 times 2 times 3 gives me 12x? And yes, it does. So that means I can rewrite this as the first term, 2x, put a minus, and then 3. So it would be 2 times 2x minus 3 to the second power. Alright, that's our answer. Let's try one more example here. Again, ask yourself, what can I factor from all 3? And I notice I can factor out a 3 as well as a letter x. By factoring out of, by factoring out of the 3x, I get 12 divided by 3 is 4, a squared, and the x cancels. Negative 2 divided by 3 is negative 4, a, b, and the x cancels. And the last one is going to be 3. The b 3 divided by 3 is 1. And then we have b squared, and the x cancels. Alright, so now with that, we have the 3x on the outside, and I notice that this guy is a perfect square, and so is this one. So let's check if it falls into that formula. You write a 2, then you take the square root of the first term. The square root of 4a squared is 2a. The square root of b squared is b, and this 2 times 2a times b gives me 4ab. Yes, it does. So that means my answer is going to be, don't forget to write down the 3x, and it's going to be 2a, the square root of the first term, minus the square root of the last term, which is b squared. And that's it. Alright, so that is one of the rules for special factors. Now let's look at another rule. The other rule is the difference of two squares. So let's bring it to view here. Alright, let me clean this up. There's a lot of erasers here. Alright, so now we're going to talk about the difference of two squares. Okay, and basically we're still going to use the perfect squares that we talked about. And if you ever find an expression that has a perfect square minus another perfect square, you can do this as your factorization. So that would be your shortcut. So let's see, this qualifies because I have a perfect square and a perfect square. So applying the rule here, I'll take the square root of the first term, it becomes a, minus the square root of the second term, square root of 16 is 4, and then I copy the first term, but I put a plus now, plus 4, and that's it. Let's try another one. I notice I have a perfect square and a perfect square. So take the square root of the first term. Square root of the first term would be 5x minus the square root of the second term, which would be a 1. Then I'm going to do it again. I'm going to write 5x, but instead of a minus, I'm going to put a plus, and that will be my answer. Alright, let's continue on. I have perfect squares for the first and second term, and I do have a minus. So square root of 16a squared is 4a, and the square root of 49b squared is 7b. Alright, then copy the second parenthesis, basically the same numbers, but instead of a minus, I put a positive. Oftentimes students ask me, does it matter if I write 4a plus 7b in the front and then 4a minus 7b on the back? No, it does not matter. So if you flip these are still good. Okay. Alright, let's go on to the next one. Next one, they're perfect squares. I know a lot of times we worry because there's a fraction there, but if you notice, 9 is a perfect square, 16 is a perfect square, so you can still use the rule. The square root of the first is z, minus square root of 9 is 3, square root of 16 is 4. And the second parenthesis would be square root of z is z, square root of the second parenthesis would be plus 3 over 4. Alright, so this will be my answer. Alright, the next one. The next one, I have a perfect square for the y, but the 8 and the 50 are not perfect squares. But again, ask yourself, can I factor anything from both? And the answer is yes, I can. I can factor out a 2. By factoring out a 2, that 50 becomes a 25, and that 8 becomes a negative 4 y squared. And now I have perfect squares. So copy the 2, and square root of 25 is 5. Square root of negative 4y squared, square root of 4y squared is 2y. So the second parenthesis is going to be 5 plus 2y. And that will be my answer. Alright, very well. Let's keep going. The next one, it is a perfect square. Remember, p to the 4th power, the square root of that is going to be p squared. So I can apply the rule, even though it doesn't say a 2 there, we're gonna still use it, because we can say this. The absolute not the absolute value. The square root of p to the 4th is p squared minus square root of 16 is 4. And then the second parenthesis would be p squared plus 4. Okay? Whoops. Now, if you notice right here, this is a perfect square and this is a perfect square. So guess what? I'm going to apply the formula again in this problem, and the square root of p squared is p. The square root of 4 is 2, so it would be p minus 2, p plus 2. Now this second parenthesis, I cannot use the rule because this is a plus. The rule only applies if I have a negative. So basically all I can do here is copy. But this will be then my factorization. Alright, let's continue and move on to the next problem. Okay, at first look, I see a perfect square, but this is an x cubed. But ask yourself again, can I factor anything from both terms? And the answer is yes, I can factor out an x. So let's do that. If I do that, then this would be 9x squared minus 25. And then we have perfect square, perfect square. So this is copy the x. Square root of 9x squared is 3x. Square root of 25 is 5. And then write another parenthesis. And this time, instead of a minus, put a plus. And there we go. Whoops. Okay. Alright, very well. So let's go on to the next problem. Letter H. So let me move the paper. There we go. again, what can I factor from these two? I can factor out a 3. So that means the 48x to the 4th becomes a 16x to the 4th. And 3 divided by 3 is negative 1. Copy the 3. The square root of 16x to the 4th is 4x squared minus the square root of 1, which is 1. And then copy again 4x squared, but this time put a plus. Now if you notice, perfect square, so I can use the rule again. The square root of 4x squared is 2x. Square root of negative 1 is 1. Then we have 2x plus 1. And we just bring this guy down because we cannot do anything with this guy because he has a plus 1. Okay, remember the rule only applies if you have a negative. Right? It only works if you have a negative. If you have a plus, then all you can do is bring it down. Okay? Alright, letter I. Letter I, at first look, we have perfect squares, but it doesn't look like the formula. There's two things you could do. Okay? First thing you could do is flip them around. Okay? But I would recommend for you to do something else. Okay? In preparation for the next chapters that are coming ahead. Okay? What I would do is, you always want the numbers, you always want the letter at the beginning. So this is correct, where the letter is the beginning. The only thing that is not good is the negative in the front. So what we're going to do is, we're going to factor out the negative. Basically, we're going to take out the negative. And negative 25m squared becomes 25m squared. And positive 121 becomes negative 121. So the negative is on the outside, and now inside the parentheses I have that special product or a special factor that we have been working on. So the square root of 25m squared is 5m. The square root of 121 is negative 11. And then you copy it again, 5m plus 11. And that's your answer. Okay? Now, I would recommend you to do this because you always want the number with the letter in the front. Okay? But had you done this instead, you'd still be correct. So let me show you what another way to do it. It would be 121 minus 25m squared. Basically, all I did is change the order of the terms. And basically, this would be square root of 121 is 11. Square root of 25m squared is 5m. And then you copy the other one, which should be 11 plus 5m. These two answers, this answer here and the previous one, they're both correct. Okay, but this here is preparing you more for what's coming ahead. So it's always good practice to put the number with the letter in the front. Okay, and we always want that first number to be positive. Okay, and that's why we factor the negative there. Alright, the next formula is the sum and difference of two cubes. And basically, let me turn my little piece of paper here. We also have what is called perfect cubes. Okay? And perfect cubes is our numbers whose cube root is our whole numbers. So here's a list of the perfect cubes from 1 to 1728. Because when I take the cube root of 64, for example, I get a whole number 4. Cube root of 343, I get a whole number 7. And so forth. And same thing applies for the numbers, the letters. For example, here I have x cubed, so cube root of x cubed becomes x. cube root of x to the 6th becomes x squared. So basically what you're doing is you're dividing the exponent by the by 3. Okay, so basically x to the 9th is 9 divided by 3 is 3. So if, for example, I had the cube root of x to the 27, for example, my answer would be x to the 9th. Okay. Alright, now that we have a general idea of cube roots, perfect cubes, then let's talk about this. Basically, this is saying that if you have any of these two things happening on your paper, if you ever find an expression like this where you have a perfect cube and a perfect cube either being added or subtracted, then you can use these formulas right here. So let's look at example number 3. Okay, here I have a perfect cube and a perfect cube. So basically what I do, I take the cube root of x cubed, which is x, and the cube root of 27, which is 3. So basically I took the cube root of that, and I got this. Now I apply the second part of the rule. The rule says take the first term, x, and raise to the square, so it'd be x squared, then put a minus, and then the first times the second, so x times 3x is 3x, and then you take the second term, which in this case is 3, and raise to the square, so 3 squared is 9. And that's my answer. Let's go on to the next one. Next one, I have z cubed minus 8. So cube root of z cubed is z, and the cube root of negative 8 is negative 2. Once I have these two, then I just follow the rule. It'll be the first one square, so z squared. Now I'm going to put a positive, and I do the first times the second, so z times 2 is 2z, and I'll do the last one squared, so plus 2 squared is 4, and that's my answer. Very well, let's continuing on. We have 125a cubed plus 1. Both are perfect cubes. So the cube root of a at 125a to the 3rd is 5a plus the cube root of 1 is 1, close parentheses. Then you take the first term and you square it, so 5a to the second power would be 25a squared. Then I put a minus, and then I'll do the first times the second, so 5a times 1 is 5a, and then I'll do the last one and I'll square it, so it'll be 1 squared is 1, and that is my answer. Alright, let's continue on. The next one, I noticed that these are perfect cubes, but the number in front of the letters are not perfect cubes. But remember, you need to ask, can I factor anything from both terms? And the answer is yes, I can factor out a 2. I mean, by factoring out a 2, the first term becomes 8x cubed, and the second term becomes negative 125y cubed. And notice that these two now are perfect perfect cubes. So let's bring down the 2. The cube root of 8x cubed is 2x, and the cube root of 125y cubed is 5y. Once I have my first parenthesis, open the second, and you take the first term and you square it. So 2x raised to the square will be 4x squared. And then we're going to put a plus, and then you're going to do the first times the second. So 2x times 5y is 10xy. And then you're going to do the last term, and you're going to square it. So plus 5y raised to the square is 25y squared. And that's my answer. Alright, very well. Let's continue on to the next problems. The next problems, I do not have a perfect cube here nor here. I have a perfect cube here, but not here. Ask yourself, can I factor anything from both? And the answer is yes, I can factor out a y. And by factoring out a y, 36y cubed is 36y squared. And then negative 25y divided by y is negative 25. So now, do I have any perfect cubes? No, I don't, but I do have perfect squares. So in this situation, we're going to use the previous rules that we learned. It's kind of demonstrating that sometimes they can be mixed, okay? And sometimes you have to distinguish which rule you're going to use. So in this case, this is a perfect square. The square root of 36y squared is 6y. The square root of 25 is 5. And then you copy the problem again. The 6y and 5 again, but instead of a minus, you're going to put a plus. And that's going to be our answer. Alright, very well. Let's do letter G now. First of all, ask yourself, what can I factor from 32 and 500? And the answer is, I can factor out a 2. But I always try to factor out the biggest number. And if we try to do that, then the biggest number will be 4. So let's factor out a 4. And can I factor out an x? No, because x only happens on the first term. But how about a y? Yes, I can factor out a y. I can factor out 2 y's, in fact. Okay. Alright. Now that we know that, 32 divided by 4 is 8. X cubed divided by, well, x cubed is going to stay there. But the y squared disappears because they cancel. And then we have minus 500 divided by 4 will be 125. And y squared would also cancel. So now I have the 4y squared on the outside, and here I have perfect cubes, which now I can apply the rule that we learned. The cube root of 8x cubed is 2x, minus the cube root of 125 is 5. So then you open another parenthesis, and you're going to do the first one squared, so it'll be 2x to the second power is 4x squared. Then you're going to put a positive, and you're going to do the first times the second. So 2x times 5 is 10x. And then you're going to do plus the second term squares, which would be 25. And that's it. That's our answer. Okay. Alright, so this concludes the lesson. And here is your assignment. Thank you very much for your time, and have a great day.